So this is problem number 40 from chapter 8.3. And this problem asks us to find the arc length of the curve. So the first thing we know is that for polar equations, the formula for arc length equals the integral from alpha to beta of the square root of dx d theta squared plus dy d theta squared all times d theta. The limits of integration should be in terms of theta, which is nice because the problem already tells us that theta should be in between pi and 2 pi. So alpha equals pi and beta equals 2 pi. However, to find dx d theta and dy d theta, we need to be able to find x, what that equals, and we need to find what y equals. So we know that in polar land, x equals r cosine of theta and y equals r sine theta. We already know that r equals 1 over theta, which I like to write as theta to the negative 1 because I think it makes what we're about to do next a little easier. So you have x equals theta to the negative 1 cosine theta, and y equals theta to the negative 1 sine theta. Now we have to do some differentiation using the product rule. And so that gives us that dx over d theta equals negative theta to the negative 2 cosine theta minus theta to the negative 1 sine theta, and dy d theta equals negative theta to the negative 2 sine theta plus theta to the negative 1 cosine theta. And here, with doing the differentiation, is why I like to write r equaling theta to the negative 1 rather than 1 over theta, because I think that makes it easier for me to see how to do the differentiation. And now that we have all the different parts for our formula, it's time to plug them all in, which tells us that the arc length of this function equals the integral from pi to 2 pi of the square root of the dx d theta squared plus the dy d theta squared, which we found earlier, which is all of this. Now it's time to integrate all of this. Now, we probably could do this by hand if we had a lot of time and space to do it, but we don't really want to because that would be really annoying and a lot of work for us. So, we can take advantage of the fact that this is a calculator problem and put the entire thing into your calculator, which is much easier for us and tells us that the arc length of the equations we started with equals approximately 0.712, and that is our final answer.